Welcome everybody, Math 103. We're continuing on with section 5.1 today, and we're working on a very important factoring technique. It's called factoring by grouping. Would you like everybody to start with a warm-up? First one, we have no variables in the second part, so we're only going to be factoring out numbers. 3 is a common factor of 3 and 15, so we'll factor that out. 3 times x plus 5. Second one, we do have a matching variable here of x, and 4 is the greatest common factor of 8 and 12, so we can factor out 4x. Now we'll take 8ax divided by 4x and get 2a, and then 12x divided by 4x is 3. 4x times 2a plus 3. Here we've got 2 x's in both of these terms, so we can factor out x squared. X to the third divided by x squared is x. So we get x squared times x minus 1. And the last one, we got 2 x's in each term, and 3 is a common factor of 15 and 8, so we'll factor out 3x squared. 18x to the third divided by 3x squared is 6x, and 15x squared divided by 3x squared is 5. So we get 3x squared times 6x plus 5. Now I want to compare these two expressions. There's a lot of similarities between them. In fact, they're exactly the same expression, except here I've got y, and here I've got x minus 1. Other than that, they're exactly the same. So if we want to factor this out, we look for the things that match in both terms, and that is the y. We have no common factors between 6 and 5. So we'll factor out a y, leaving 6x plus 5 inside the parentheses. Well, now we're going to do the exact same thing over here. We're going to factor out what is in common between these two terms. And what's in common is x minus 1. So just like I factored out y, I'm going to factor out x minus 1. And what we got remaining here is what we had up here after we removed the y. Well, here we're going to remove the x minus 1. And we get the same thing. What remains is 6x plus 5. So that goes in the other parentheses, just like over here. So there's the factored form, x minus 1 times 6x plus 5. So we can factor out binomials, and that's going to be an essential step in factoring by grouping. So your turn number 1, I'd like you to factor the binomials out of those two expressions. So the first one, we're going to factor out the 5x minus 7. And then what remains after we remove that is 2x minus 9. So we get 5x minus 7 times 2x minus 9. And the second one, the matching part is 4x minus 7, so we're going to factor that out. And what remains after we remove that is 5x plus 2. So the factored form is 4x minus 7 times 5x plus 2. So we're going to use factoring by grouping on 4-term polynomials. And the strategy will be to factor the first two and then factor the second two terms. And we're going to factor out such that just like over here, the expression inside the parentheses will match. So what can we factor out of the first two? Well, we got 2 b's in each of those, so we can factor out b squared, leaving b plus 1. So when we factor over here, we want to get b plus 1 in parentheses. So if we factor out a 3, we get exactly that, 3 times b plus 1. And now this problem looks just like these. So now we know what to do. We're going to factor out this matching binomial. So that goes out front. And what remains after we remove the b plus 1 is b squared plus 3. There's the factored form. B plus 1 times b squared plus 3. Your turn, number 2. So in this one, we can factor out an x squared from the first two terms. And when we factor out that x squared, we get x plus 4. And over here, we want to factor so that we get a matching x plus 4. So let's try factoring out the 2. And we get 2 times x plus 4. So we got our matching binomials. So next step, we're going to factor those out. So we get x plus 4. And what remains is x squared plus 2. X plus 4 times x squared plus 2. All right, next one, we can factor out x squared again. And in fact, we've got a common factor of 3 in between 3 and 6. So we can factor out 3 x squared. And it gives us x plus 2. So over here, we want to factor out so we get a matching x plus 2. So we're going to factor out a negative 2 and get x plus 2. All right, now we got our matching binomials, so let's pull those out front. X plus 2, and what remains after we remove those is 3x squared minus 2. X plus 2 times 3x squared minus 2. And with all these, we should FOIL the check. So I'm just going to do a quick FOIL here. First, 3x squared times x gives us 3x to the third. Outside, negative 2x. Inside, plus 6x squared. And last, minus 4. Now some polynomials will have more than one variable, and so you got to be careful to only factor out things that match. So the first one, we got xy over here, but we will only have x in the second term, so that means we can only factor out an x. And the greatest common factor of 2 and 6 is 2, so we'll factor out 2x from the first two terms. And get y minus 3. Now we want to factor over here, so we get a match of the y minus 3. So if we factor out 7 from there, we get 7 times y minus 3. All right, now we've got our matching binomials. So we're going to pull these out. And get y minus 3 times 2x plus 7. Your turn, number 3. Got 4 of them here. First one, here we've got no variables over here, so we can only factor out a number. Greatest common factor of 4 and 8 is 4, so we get 4 times x plus 2. Now over here we've got matching a's, so we can factor those out. So plus a times x plus 2. So we've got our matching binomials. We'll pull those out front, get x plus 2, and then 4 plus a. Second one, greatest common factor of 2 and 12 is 2. And we can also factor out an x because that appears in both terms. 2x is the GCF. And then inside the parentheses, a plus 6. So we want to get an a plus 6 over here, so we'll factor out a 3 and get a plus 6. A plus 6 times 2x plus 3. Here, greatest common factor in 4 and 8 is 4, and we've got at least one x in both of those, so we'll factor out 4x. 4x squared divided by 4x is x, 8x divided by 4x is 2, so we get x plus 2 inside the parentheses. Now here we've got matching variables of a, so we can factor out an a, and the greatest common factor in 5 and 10 is 5. Subtract out. Factor out negative 5a, and that gives us x plus 2. Notice in this case, we had 2 positive signs here and 2 negative signs here, so that means we had to factor out a negative value to turn those positive. And we'll talk more about that in a moment. Next step, factor out the matching binomials, x plus 2, and that what remains is 4x minus 5a. Alright, here we've got no match for the a, so we can't factor that out, but we do have 2 x's, so we're definitely going to factor out an x squared. Greatest common factor of 6 and 15 is 3, so we're going to factor out 3x squared. Now 6ax to the third divided by 3x squared is 2ax. 15x squared divided by 3x squared is 5. So that gives us, minus. So we get 2ax minus 5. So over here, we want to get this matching binomial. So that means we're going to have to factor out negative 4. And that gives us 2a minus 5. And there's our matching binomial. Oh, nope, there's a mistake. That is 2ax minus 5. There we go. Now we got our matching binomials. Alright, let's bring this out front. 2ax minus 5, and then we got 3x squared minus 4. Now, like I mentioned, in order to make the binomials match, sometimes we need to factor out negative values. So be real careful about watching your signs. So with this one, signs go positive, negative, and then the second two are negative, positive. So they're opposites of each other. And that tells me that I'm going to have to factor out a negative value here in order to turn the signs of the terms inside the parentheses to positive, negative, just like I'm going to get over here. So let's see how that works out. So we've got an x in each of these, and the greatest common factor of 8 and 12 is 4. So we're going to factor out 4x to get 2a minus 3. So I want to match 2a minus 3, positive, negative. I've got negative, positive, so I'm going to have to switch them. So if I factor out negative 3 over here, negative 3 times positive 2a gives us the negative 6a. So we've got a match on the positive first one here. And then 9 divided by negative 3 is negative 3. So factoring out a negative ends up switching the signs on these two when you get inside the parentheses, and that matches the first one. So that gives us 2a minus 3 times 4x minus 3. And that brings us to your turn, number 4. Another 4 practice problems there. Part A, we can factor out a 2 from the first two terms. You get 2 times x minus 4. And now we got to make the first one positive, so we're going to factor out a negative a. Negative ax divided by negative a is positive x. And 4a divided by negative a is negative 4. So that gives us the matching binomials x minus 4. So we'll pull those out front. So we get x minus 4 times 2 minus a. B. Here we got a greatest common factor of 3, so we can factor that out of the first two. And you get 2 minus x. And then over here we got matching y's. And I want to make sure this one turns out positive, so I'm going to factor out a negative y. So we got negative 2y divided by negative y is positive 2. And then positive xy divided by negative y is negative x. So there's our matching binomials, 2 minus x. So we get 2 minus x times 3 minus y. Next up, here we can factor out a b squared and get b plus 5a. And then over here, we want to get positive values, so factor out a negative 2. Negative 2b divided by negative 2 is positive b. Negative 10a divided by negative 2 is positive 5a. So factoring out that negative effectively switches both of those signs to positive, so I can match the binomial. So now we got b plus 5a times b squared minus 2. Last one, and there's a couple different ways we can do this one. We could either factor out a negative 3 or a positive 3. You'll get the same result either way, so it doesn't really matter. We have to do a little switching around to get them to equal each other. I'm going to go ahead and factor out a negative 3, and then we've got matching x squared, so negative 3x squared. So we do negative 9 bx to the third divided by negative 3 x squared. That gives us 3bx. Now we'll do 12x squared divided by negative 3x squared minus 4. Alright, so now we want 3bx minus 4 in parentheses over here, so we can factor out a positive 4. And that gives us 3bx minus 4. So here, by factoring out a negative in the beginning, I end up switching these signs to match these. So it doesn't really matter if you get these signs to match these or these signs to match these, as long as you get matching binomials. It's all that matters. Last step, 3bx minus 4 times negative 3x squared plus 4. Now the next one's a little different. Okay, so let's apply our procedure to this one. Here we've got no matching variables, but we can factor out a 2 to get 3y squared minus 10w. And then over here, I can factor out a matching y, but there's no common factors between 15 and 8, so I'll just factor out the y and get 15 minus 8w. So we have a problem here, because we do not have matching binomials. And there's no way that I can factor something out of here to make matching binomials. So when that happens, we get stuck like this, we need to rearrange the order of the terms. Now you can just do this by trial and error, but if you notice some patterns, there will be a lot less error in your trials. So what we can do is we can get the y's next to each other so that we can factor out a y. So I can either move the 8yw over here or the 15y over here. And I don't think it matters which one. I think we'll get the same answer either way. So I'm going to go ahead and move the 15y over. So it gives me 6y squared minus plus 15y. Make sure you keep the sign with the term. And then the negative 20w comes down here. Actually, no, I'm going to go negative 8yw first, and then negative 20w. And the reason is, we have one more y here than I have here. I want the same pattern as I have over here. Here I have 2 y's, here I have one of them. So I have one more y here than I have here. Same pattern. If you have the same pattern, it becomes a lot easier. All right, let's try it. Here we can factor out 3y and get 2y plus 5. And over here I can factor out a negative 4. Oops, negative 4w. So we have w's in both of these. And that gives me 2y plus 5. And now I've got the matching binomials. Rearranging them made it possible to do the factoring by grouping. So now we got 2y plus 5 and 3y minus 4w. Your turn, number 5. So with this one, I want to get either an n over here or an m over here, so I can factor out either m or n. Doesn't really matter, so I'm just going to go with 9mn plus 12n. And now I've got an n in the first one, no n in the second one, so I want to do that. I want to repeat that pattern in the next two, so I'm going to put negative 3n first, and then minus 4 second. Now I've got them arranged in a nice order here, so I'm going to factor out 3m. So you get 3n plus 4. And here, I've got 3n and 4 matching terms, but the wrong sign, so I'm going to factor out a negative 1 to turn them positive. Turn them into positive 3n plus 4. All right, now we've got our matching binomials. So 3n plus 4 and 3m minus 1. Next up, definitely want to get the a to the 5th power terms next to each other. Now for the next two, the b is in the second term, so I want the b in the second term over here as well. So I'm going to do negative 3 minus 6b. And that should factor well. I factor out a to the 5th to get 1 plus 2b. And over here, I want to get a 1 plus 2b over here as well, so I'm going to factor out negative 3. And I'll turn this into 1 plus 2b. So I get 1 plus 2b times a to the 5th minus 3. Next up, got b to the 3rd power. Definitely want to factor those out. So I'm going to put those two next to each other. So b to the 3rd plus 5ab to the 3rd. Now I'm going to arrange these two such that it kind of matches this pattern. So I've got a 5 in the second term, so I definitely want the bigger number to be second. So I'm going to do minus 2 minus 10a. And here the a is in the second term, here the a is in the second term. So that should work. So we'll factor out b to the 3rd power. You get 1 plus 5a. And over here I can factor out negative 2 and get 1 plus 5a. So our final answer here will be 1 plus 5a times b to the 3rd minus 2. Last one. So we've got an r squared here. We've got two terms with r over here. Let's try the 12ry. All right, now I've got a y in the second term, so I'm going to get the y in the second term over here. So I'm going to bring down negative 3rt minus 2ty. Now we've got kind of the same pattern here. Bigger number, smaller number, bigger number, smaller number. No y, no y. So same pattern in both pairs. So here we can factor out 6r. 18r squared divided by 6r is 3r. 12ry divided by 6r is 2y. So we get 6r times 3r plus 2y. Now over here, I'm going to factor out the negative for sure. So I want to turn both of these positive. And then we got matching t's. So I'm going to factor out a negative t. So that gives us 3r plus 2y. So our binomials match. Last step, 3r plus 2y. Once we remove that, we've got 6r minus t. So this is a really important factoring technique. Make sure you get this one down. We'll be using it throughout this chapter. Have a great day, everyone.